So this is part 2 of the applications of systems of linear equations. We did part 1 where we were able to get through 3-word problems, and again I wanted to give you as many examples as I could to kind of help you out because this is probably the tougher section of the unit. And so we have 3 more problems that we need to go through. So kind of review, remember there are 4 steps: identifying the variables, write 2 equations, solve the equations, and write a sentence to answer the question. So remember there are 3 types of problems. We did how many of each type on the previous video. We did 1 comparing 2 things, and then we're going to do the mixing liquids at the end. So here's your 2 types. Remember, we're comparing 2 things where we do 1 equation for one company and 1 for the other. So here's your second problem when you're comparing 2 things. So you're trying to figure out which catering company would be the best for the party. So notice we have company A who charges $100 plus $3 per person. And company B charges $60 plus $5 per person. So after how many people, there's that question of what I'm trying to find, how many people will it cost the same price. So my 2 variables, we can change the amount of people, or that's what we're trying to figure out. So P, we're going to represent the number of people. Again, I just don't write people, I write number of people because I'm asking for how many people. And then to figure out, I'm not going to use P for price because I don't want 2 P's. That'd make it confusing. It would make it the same variable. So I'm going to do C for cost, or we could say it equals the price. How much it's going to cost us. So again, when we're comparing 2 things, we're going to have an equation for one company and an equation for the other. So in the first company, if I want to figure out my cost, I have to pay the $100, no matter what, plus $3 per person. So if I have 10 people, I take 3 times 10. So that's company A. So company B, I'm going to have my cost, but this time I get $60 plus $5 per person. So to solve this, again, you could use elimination, you can use substitution, you can pick your favorite between them. Again, I'm going to use substitution. I think it goes a little faster. So I'm going to take C equals this. So I'm going to replace that C in there. So I have 100 plus 3P equals 60 plus 5P. Solve for my P, which stands for the number of people who can have for these 2 companies cost the same, equals 2P minus 60. So I have 40 equals 2P divide by 2. Alright, so P equals 20. So I now need to do my last step, which is answering the question. So I can write after 20 people, they cost the same. Again, I don't need to answer the same price because all I'm asking is for how many people will the 2 companies cost the same. Alright, so we are on the last type of problem, which is your mixing liquids. This is the tougher of the 3 when we're solving systems because it kind of has a little trick, but it also compares a lot to the first 2 problems that we did where we're trying to find how many of each type, because what we're doing is trying to find how much of each liquid would make the desired combination that we want. So number 5, the car manual recommends that you use at least 89% octane gas. Your car 16-gallon tank is almost empty. How much regular gasoline, 87 octane, do you need to mix with premium gasoline, 92 octane, to produce 16 gallons of 89 octane gasoline? You have to mix gasolines a lot when you're working with small engines and other things. So that's what we're doing. We're taking 2 types of gasoline that is not what we want to make one that's in between. We are mixing 87 gasoline, which is like 87%, with 92 octane gasoline, which is like 92%, to create 89%. So notice we have 1 lower and 1 higher, and then we have 16 gallons. So how many of each regular gasoline? So we're going to have X represent the number of gallons of 87%, and Y equals the number of gallons of the 92%. So then I need to set my two equations. So just like at the first one, I have a total 16 gallons. So I have how many X gallons plus how many Y gallons equals 16. Those two add together have to equal 16. It's the second equation that's a little tricky. I want 87% of X. So I have 87 for X, just like we did money, like you had $6 cost this one. We have 87% of X plus 92Y equals, we want 89. Now the trick part is that we can't just leave it as 89. We only want 89% of the 16 gallons to be what we want. So I have to take it times my total. So you might want to put a little star here because that is the kind of the big difference between this type of problem and the first two we did when we were figuring out how many of each type. And then from here is just solving the system. Again, I'm going to use elimination. So I'm going to solve by elimination by multiplying a negative 87 through. So I'm going to write my two equations. I have negative 87x minus 87y. Negative 87 times 16 gives me negative 1,392. And then I did not change my second equation. 92y. And then calculate this out. 89 times 16 is 14,024. So we have 5y equals, adding these two up, we get 32. 5. So y comes out to be 6.4. Alright, so if y is 6.4 and I only have 16 gallons, so I can take 16 minus 16, or 6.4, and that gives me 9.6. So then I can write my sentence. I need 9.6 gallons of 87% and 6.4 gallons of 92%. Alright, so that one's a little, this is probably the most difficult one you're going to do, and again, it's set up like the first two, but we kind of have this last step. Alright, so let's look at one more. This custodian needs to make 5 gallons of cleaning solution. That is 5% chlorine by mixing together 2% chlorine solution with a 7%. So again, we have one lower, one higher to get one in between. How much of each solution should they use? Alright, so I'm trying to figure out how many solution of each type. So I have 2% and 7%, and we're making 5%. And again, I have a total of 5 gallons. So X is going to represent the number of 2%, or number of gallons, 2%, and Y, we're going to represent the number of gallons of 7%. So then I'm going to have my two equations. So again, I have a total. How many gallons total do I have? So X plus Y equals 5. The sum of the two, the total, which means addition. And then again, we can combine, just like with money, of the 2% of X plus the 2% of 7, or the 7% of Y. So I have 2X plus 7Y. And then here's your trick thing. I have 5%. And then times how many total, so that how many total gallons you want, so 5. One thing you might ask is why don't we need to make the percents into decimals when we're working with them? What's nice, if you keep everything as a percent, the regular percent without making them a decimal, you don't have to worry about it, but if you change one, you have to change them all. So I'm going to use elimination again because they line up, so I'm going to multiply by negative 2. So I have negative 2x minus 2y equals negative 10. I can just rewrite my second equation while I'm doing my third step, which is the solving step. So I have 5y equals 15. Divide by 5, y equals 3. Well, since I only have a total of 5 gallons, if y is 3, then I have 2 of the x. So the last step, which is probably the easiest one, is just writing a sentence of your solution. He should use 2 gallons of 2% and 3 gallons of 7%. So that concludes the second portion of this video. Remember to watch the first portion if you watch this one first. Remember the 4-step process. You have to define a variable, set up your 2 equations, solve the system, and then write a sentence that answers the questions. And again, we have 3 types. How many of each type? You're going to have an equation that represents the total and one to figure out costs. And then we have comparing 2 things, one equation per service that you have, one for company A and one for company B. And then the mixing of liquids. Remember, you have the total. And then you need the amount used. And then remember, the total amount needs to times by the percent. That's the kind of trick. One last reminder, make sure you do your reflections so you have credit for watching not this video, but both of them.